Hello, in this video I'm going to talk about focal length. Here we have a picture of a camera, and let's assume this is a super zoom lens. You can zoom in, you can zoom out. When you zoom in, you have telephoto lens. When you zoom out, you have wide angle lens. The angle of view changes as you zoom in and zoom out. So the telephoto lens is just like a telescope. The wide angle lens is exactly the opposite. Now you understand the angle of view. You may ask a question, hey, if I have a telephoto lens, it has narrow angle of view. Now I take a lot of pictures and stitch the pictures together. Do I get a wide angle lens view? On the other hand, if I have a wide angle lens, I crop out the center part and just enlarge the picture. Do I get a telephoto lens? Well, the answer to this question is a bit complicated, but if your camera sensor has infinite pixels, so pixel density is infinity, and each pixel has maximum quality, so every pixel, doesn't matter how small it is, it can capture the light and truthfully reflect the view. And if your lens is perfect, there's no optic imperfections. If the sensor's infinite pixels, lens's infinite resolution, then yes and yes. The answers to both questions are yes. If your lens is perfect, your sensor has infinite pixels, you can just use a telephoto lens and take a lot of pictures and stitch them together. I assume you have very steady hands, yeah. When you shake your camera and stitch them together, picture may not align very well, yeah. I'm just theoretically speaking. If you have wide angle lens to take picture, you can just crop out the center part and then your picture becomes a telephoto lens picture. Because you have infinite pixels, you have infinite resolution, even though you crop out a tiny piece, you enlarge the photo, you still get a very high quality image. So if your lens is perfect, your sensor is perfect, one ultra wide angle lens will suffice. You do not need any zoom lens at all. Because whenever you need to crop it out, you just pick a tiny piece, enlarge the picture, you still get a high resolution. So now you understand, under perfect condition, you can just use a single wide angle lens. The reason we have so many different lenses is because the sensor does not have infinite many pixels. It has finite number of pixels, say 24 megapixel sensor. If you use a wide angle lens to take a picture of a wildlife, like a bird that is 200 feet away, then the bird on the sensor will be minuscule. When you increase the image size, you will get a very low quality image because there are not enough pixels. So the reason you have these zoom range, or you can use a collection of prime lenses of different focal lengths, because you want to make maximum use of your sensor. You want to use your sensor because we do not have infinite many pixels. Now I will just explain what these different focal lengths are used for. Obviously, for the telephoto lens, they're useful for wildlife, because if it's an animal, wild animal, chances are you cannot get too close to it, right? So telephoto lens is like telescope. Sports, like playing soccer, you cannot get onto the soccer field, right? You have to stay outside the soccer field with the telephoto lens to take picture of the athletes. The wide angle lens is very good for example, landscape. You have beautiful mountain range in the background. You want to take a wide view. It is also good for indoor situations, like you're indoor in the museum or something. You want to take a picture of the environment. Yeah, you can use a wide angle lens. And the part in the middle, by the way, when I talk about focal length, I'm talking about a full frame camera. If you're using a micro four third camera, you have to divide that focal length by 2. If it's a crop sensor APS-C camera for Nikon, Sony, Pentax, and Fuji, the factor is 1.5. You have to divide your focal length by 1.5. If it's Canon, the number is 1.6. So you have to do the math. Here I'm using full frame camera. So for full frame camera, if the focal length is between 50mm and 58mm, then it's called a normal. Yeah, that gives the normal view. A lot of people, if you read online, call 50mm the kind of normal lens, the standard 50mm lens. There's nothing magical about a 50mm. The normal range is about 50 to 58mm on the full frame camera. The reason 50mm is talked about so often because many decades ago, a company was able to, I think it's Leica, was able to build these 50mm lenses, and it became a tradition. They're very easy to make. and they got this lens formula, lens design, so it becomes the normal lens. But in fact, anything between 50 and 58 millimeter will generally not produce any distortionary effect when you look at those pictures with the naked eyes. So I will talk about lens kind of compression, extension of space. Before I continue, I'd like to talk about human vision. We humans have two eyes, and even though both eyes can see a lot of stuff, it's an ultra wide angle lens of about 17 to 20 millimeter. Only the middle part is actually the part we pay attention. So the human angle of view, human eyes, there's no one-to-one mapping between human eyes and camera lens, because we humans have two eyes, and when both eyes see something, our brain will do something to combine the images. Yeah, people sometimes have brain injury or had brain tumor, then they see two images. That's because their brain's no longer working properly to combine the images. But for most normal people, we see a combined image of both eyes. And the mid-peripheral view is the key. It's about the same angle of view of a 50 to 58 millimeter lens on a full frame sensor. That's why we call the 50 to 58 millimeter on the full frame the kind of normal lens. When you take pictures with these lenses, it's a safe bet. If you look at the picture, it looks very normal, just like you would see with your naked eyes. Next, I'm going to show some pictures of normal lenses. Most of these pictures were taken with a 50 millimeter prime lens on the full frame sensor. Some were taken with like 48 equivalent or 55. So they are all around the normal view. Yeah. So when you look at these pictures, it's very natural. There's no kind of distortion, or it just looks normal, just like you would see things with the naked eyes. Another picture. These are all pictures I took in Northern California. It is very natural. Can also show some pictures of portraiture. This is a picture of a portrait of my wife, taken with a 50 millimeter prime lens. You can see the guy in the background. Obviously, he's in the background. It has f1.8 lens. It has very shallow depth of field, so he's kind of blurry. But this kind of ratio is the size between the two heads is exactly what you would expect when you look at things with the naked eyes. When you use a wide angle lens to take this picture, if my wife's size does not change, this person in the background will become much smaller. When you use a telephoto lens to take a picture of my wife, if the portrait of my wife does not change in size, the guy in the background will become much larger, as if he was very close to my wife. So if you use wide angle lens, this guy looks far away. When you use telephoto lens, this guy would have looked much closer. This is the expansionary effect of compressionary effect of wide angle lens and a telephoto lens. Now I will explain why wide angle lens extend the space while the telephoto lens compress the space. This picture was taken with a 200 millimeter telephoto lens. By the way, the 7200 f2.8 lens used to be my workhorse lens. I used it, took a lot of pictures. Yeah, it's a great lens. Now you can see this picture was taken Cape Cod. You can see the waves. They looked very close to my daughter, right? Because it's a telephoto lens, 200 millimeter, it compresses the space. In reality, the waves are much smaller, are much farther away. Because it's telephoto lens, it compresses the space. How does this happen? Well, think about two people of the same size. One person is 4 feet away from you. The other person is 5 feet away from you. If you take a picture of them in the same frame, even though they're of the same size, the person 1 will appear 20% larger than person 2, right? 4 versus 5. Now, if you use the telephoto lens, you move back, and you're 100 feet away from the one person, 99 feet away from another person. Then you take a picture with the telephoto lens. Then the size difference between the two people are much smaller, only at 1%. Why? Because 99 versus 100 is 1% difference. 4 versus 5, 20% difference. So when you use telephoto lens, Why do things get compressed? Because when you look at this picture, like my daughter, because she's so large in the picture, this picture is on this 32-inch 4K screen. My eye is probably 2 feet away. So my brain will give the illusion that I was very close to my daughter, when in reality the picture was taken with a telephoto lens. I was very far away. That explains why the background becomes so much closer, because the same reason, 1% versus 20%. My brain tells me, oh, that thing should be 20% smaller, but when I see it, it's only 1% smaller. So my brain thought this guy was very close to me, when in reality I was very far away, taking a picture with a telephoto lens. This discrepancy produces this compressionary effect. Now let's take a look at a wide-angle lens picture. This picture was taken with a 35mm not prime lens, zoom lens actually, 16 to 35, f2.8 here. This picture was taken in Iceland. You can see the mountain, the glacier in the background. They appear much farther away because it's a wide-angle lens. In reality, they're much closer. They're much bigger. My wife and my daughter at the time was in 4th grade, I believe, yeah. She was probably 5 feet 1. Obviously, she was still a lot shorter than my wife. But if you look at this picture, my wife is more than twice the size of my daughter, even though they're just a few steps apart. That's because wide-angle lens, it extends space. It does exactly the opposite of telephoto lens. Even though my daughter was just a few steps away from my wife, she appears much smaller and gives the illusion that my daughter was a very young kid when she was already over 5 feet. So this is the kind of expansionary effect of a wide-angle lens. The same reason, even though I was kind of close to the subjects, when I look at this picture on the computer screen with a normal distance, my brain plays the trick, tells me, oh, actually this person is very far away, or this person is very small, yeah, because of the expansionary effect, exactly the opposite of telephoto lens. So you need to bear in mind, wide-angle lens extends the space. Things close to you becomes much larger relative to the things that's farther away, while a telephoto lens does exactly the opposite. The whole space got compressed. This picture was taken with the telephoto lens in Iceland. The island in the background actually was very far away from the coast, but because the compressionary effect, the telephoto lens brought the island much closer than it really is. This is a picture I took in San Francisco. This island is a prison called Alcatraz. You can see the mainland in the background looks much closer. In reality, there's a significant distance between this island and the land behind it. Compressionary effect of telephoto lens. This picture was also taken in Iceland. You can see this little ship and the mountain in the background. Because it's telephoto lens, the mountain appeared much closer than they really are. Now I have explained the expansionary effect of telephoto lens and compressionary effect of the expansionary effect of the wide-angle lens and compressionary effect of the telephoto lens. Here are some tips about photography. The full-frame camera, again, you have to do the math yourself if you do not use a full-frame camera. So for 50 to 58mm range, it's the safe bet. This picture was taken with a 55mm lens. You can see it looks natural. The Prudential Tower in the background, this is Boston, does not look much closer or much farther away. This is exactly what your eyes would see. So it looks natural. The 50 to 58mm, the standard range, is safe bet. It's very difficult to screw up because it's just what your eyes would see, right? Obviously, sometimes you can still mess up with the composition stuff, but from the perspective, in the sense of perspective, it's difficult to screw up. You do not produce any kind of a weird compressionary or expansionary effect. 50-58, it's boring, but it's safe. The same cannot be said about wide-angle lens or telephoto lens, because the wide-angle lens have this expansionary effect, distortion, and telephoto lens has this compressionary distortion. You can screw up big time, but you can also use their expansionary or the compressionary effect to your advantage. Here's the picture taken with a 20mm prime lens. It's a wide-angle lens. You can see there this a planter thing in the street. It looks much bigger compared to the background. By using an ultra-wide-angle lens, you emphasize the stuff in the foreground. It becomes much larger. So if you have something that's interesting, beautiful in the foreground, like some wild flowers, you can use ultra-wide-angle lens to take foreground, some beautiful flowers, background is spectacular mountain range. This is a tried and true formula. For the wide-angle lens, you have to be careful what is in the foreground because they got exaggerated. The foreground is a pile of poop, it will be a gigantic pile of poop. So that will ruin your picture. Another example, if you're taking a picture of a model, she's seated on some flight of stairs, you use a wide-angle lens, then because her feet is closer to you, the feet will look very large, the legs will look very long. If you use telephoto lens, the exact opposite would happen. The legs will look tiny. The legs got compressed. It looks very short leg, which is very ugly. If you're taking pictures of a group of people, and if you use wide-angle lens, you need to make sure that, or even standard lens, you need to make sure that the big guy is in the back row, if you put the big person on the front row, he probably looks 3 times bigger than the person behind him or her. So you need to make the arrangement. So that's the kind of expansionary and compressionary effect of wide-angle and telephoto lens. It affects your composition, how you arrange your subjects, what to put in the foreground, what to put in the background, this kind of stuff. The telephoto lens also gives a lot of flexibility in the sense that you can choose your background. This is a picture of my daughter playing at her school playground. There is some random guy in the background. They are blurred out because I believe I used a 85mm prime lens, 85 1.8, shallow depth of field. If there's something unpleasant in the background, a trash can, like very colorful, blue-colored trash can, I can just move around a little bit and my background would change completely. The telephoto lens background, because of the narrow angle of view, you can just move a few steps, move your subject a little bit, the background would change completely. So it gives a lot of control over background. The wide-angle lens, the opposite is true, because it's so wide, it's very difficult to get rid of unwanted elements. In your photos, the composition becomes much more important with a wide-angle lens. Next, I'm going to talk about zoom lens versus prime lens. Zoom lens can change its focal length, and prime lens is fixed focal length, like 50mm prime lens. This is a picture taken with a 50mm prime lens. The zoom lens offers a lot of flexibility in composing a shot. You can zoom in, you can zoom out. Zooming with the feet is not the same as zooming with a lens. Some people say, oh, you got a prime lens, so what? You can zoom with your feet. That's not the same. When you zoom with your feet, move in, move out, your perspective changes. So you will no longer get the same picture because your position relative to your subject has changed. This picture was taken with a 50mm prime lens at Concord, Massachusetts. It's a statue of the Minuteman. It was taken with a 50mm prime lens. In order to fill the sensor of this image, the guy is standing on a high pedestal. In order to make full utilization of my image sensor, I had to get very close to this guy. And as I move close to this guy, because he's on a pedestal, I have to shoot from below. So zooming with your feet changes your perspective. This is the statue of Harvard inside of Harvard University. When I took this picture, I used a 120mm lens. By the way, you can see the shoes is very bright because for whatever reason the tourist touches his feet. So this statue is also on the pedestal, but because it's a telephoto lens, I was able to have a much flatter view because I can still fill the image sensor with the statue without having to move too close. So that's the telephoto lens. So being able to zoom in and zoom out is not the same as zooming with your feet, getting close. Because when you zoom with your feet, your perspective changes. You can no longer get the same picture. So the zoom lens offers a lot of flexibility. But why do people use prime lens? Because they're faster in general. Today there are crazy zoom lenses. Like Canon has like 28-70 f2 zoom lens, f2. But in general, you can still get a much faster lens, f1.2, f1.4. prime lens. They are relatively inexpensive. Their image quality is very good. In general, the prime lens image quality is better than zoom lens. Okay, this is my video. I hope you enjoyed it. Thank you.